All right, welcome back. This is James Camp, your friendly computer science professor from Lee College in Baytown, Texas. We are talking today about variables and types of variables and how they're stored in computers' memory. So, if you think about memory, it's got a series of kind of boxes, okay? And those boxes each hold a 1 or a 0. Okay. Each one of those boxes is what we call a bit. Okay. A bit is either a 1 or a 0. We say that the bit is set if it's a 1, or that it's unset or cleared if it's a 0. 8 of these bits put together are called a byte. Okay. Now, if you add up all the possible combinations of 1s and 0s that can fill a byte, okay, you could have all 0s, which would be a 0. You could have all 1s, which would be the number 255, which is 1 less than 2 to the power of 8. Okay, so 2 to the power of 8, that's 8 bits. 2 possibilities, 1, 0, to the power of 8 bits is 256. My pen is not entirely working. Okay. Now, 256 is enough to hold all the letters in the English alphabet plus all of the other symbols on the keyboard. And so 1 byte is all you need to store all the characters in the ASCII American Standard Code for Information Interchange. It's all you need to do to store all of the ASCII letters and numbers and symbols. But if we want to do any serious math, occasionally my bank account has more than $256 in it, right? Right after I get paid. Not for very long after that, but right after I get paid. So we might want a number that a memory box that's bigger than a byte. In which case we just extend this another 1, 2, 3, 4, 5, 6, 7, 8. Another 8 blocks, and now we've got a 2-byte memory box. And this kind of memory, or this kind of number that we've been describing so far, is called an integer. That is, it doesn't have anything after the decimal point. It's a whole number. So we fill this on up with more 1s and 0s. And now we've got a 2-byte integer, which will, 2 to the 16th is something like 32,000. Now, we could go from 0 to 32,000, but that's not really the way we deal with integers, because if you remember from math class, an integer can have either positive or negative values. So really, we set off this first box as being the plus minus bit. If it's a 0, it's a positive number. If it's a 1, it's a negative number. Okay, and then everything else counts as the integer. So really we're going from negative 16,000 up to positive 16,000. Still not big enough for a lot of kinds of everyday math. So we're going to deal with even bigger integers. We're going to deal with one, 2, 3, 4, 5, 6, 7. Boom. 1, 2, 3, 4, 5, 6, 7. Boom. 1, 2, 3, 4, 5, 6, 7. Boom. 1, 2, 3, 4, 5, 6, 7. Boom. There. That is a 4-byte integer, and that is what we typically use in computer programming today. There are also the possibility of an 8-byte integer. 4 bytes, if you multiply 8 bits per byte, that's a 32-bit integer. 8 bytes is a 64-bit integer. Have you heard of 32-bit and 64-bit computing? Okay, you may have heard that applied to your processor is either 4-bit or is either 32-bit or 64-bit. That has to do with the size of the integer that it uses to measure memory locations. Okay, how many gigabytes of memory it can think about internally. So a 4-byte integer in C++ gets the name int. Okay, int. And what happens when we declare a variable, computer scientists often like using the words foo and bar to describe their variables. So we'll go with int foo here. When we declare int foo, what happens is that we take this whole chunk of memory here and set it aside as one big memory box, and we put the label foo on it. And we tell the computer to interpret whatever's in foo, whatever series of ones and zeros is there, we tell it to interpret that as an integer. Forgot my semicolon. The compiler would yell at me. Okay. There are also, we can also make a 4-byte floating point number in C and C++. The type for that is called float. So we could call this float bar, foo and bar. Bar sets aside another 4 bytes of memory. But this time, it tells the computer to interpret the first about 2/3 as an integer or as a number, and then the next part as a power that first number floats to. Okay, so you could have 1,337 to the times 2 to the power of 450, okay, and that gets you a really big number. Or you could have 1,357 times 2 to the negative 450, which gets you a really, really small number. Okay, and that's how the computer handles floating points. The problem with that is that 4 bytes is really not enough, since we are splitting it up into the number and the power. 4 bytes isn't enough to get you enough precision that you don't have a lot of rounding errors. So what is more often used in C++ is the 8-byte floating point, which gets the name double. So we could have double bar 2. Or it looks like I called it barred instead of bar 2, but whatever. Double barred is now takes up twice as much memory as float bar, but that means it has 2. It has 2 to the 2, or it has. You take the amount of information you can store in bar and you square it. Okay, you have much exponentially higher precision than floating point than the float type has. So in practice, in practical use of C++, nobody uses the float type anymore. Everybody is going to use the double type. And if you use the C++ auto function to automatically type a floating point number, it's going to pick double for you. Okay, real quick, 2 more types that we have. We have bool. Bool is a 1-bit variable. Okay, it can either be 1 or 0. 1 is read as true, and 0 is read as false. It's used to store Boolean logic, true-false values. And then we have char, which stands for character, and that's a good old-fashioned 1, 2, 3, 4, 5, 6, 7, 8. A good old-fashioned 8-bit integer, except it's not interpreted as an integer. It's interpreted as the letter A, or the lowercase letter a, or the space character, or the parenthesis character, or the semicolon, or any number, any letter that you could, any character that you could print on the screen or type on the keyboard could be a char variable, unless you have a non-American keyboard that has some of those fancy European characters or something on it, in which case you need a different type to hold that. Character only works for the American standard character set. Okay, so hopefully that introduces you to the idea of what a variable is. It's a name that goes with a particular memory box of a particular size. The size of that memory box and how the ones and zeros inside it are interpreted is determined by the type that you give the variable when you declare it. Int, or double, or bool, or char. Okay? That gives you just enough computer science to hopefully understand the discussion of variables and types in lesson 3. So off you go. Good luck and happy programming.